So here is a training video for SuperSCADA's data types and storage. So we'll go through the different types of data, or at least the common types. We'll talk about where the data is stored, and I'll show you a typical layout, what individual values are called and how they're referenced, and then we'll show you actually how to define some of these values. So the main different types of data are digital. So these are on-off signals, true-false signals, and so on. Then you can have integers. So integer 8 would be a whole number with 8 bits. So that means a number from -128 up to 127. You can have integers with 16 bits, which are whole numbers up to approximately 32,000. Integer 32s, whole numbers with much more resolution, and you can even have integer 64s in some occasions. Then float 32 means a real single precision floating point number, so that means a number with a decimal point. And you can have float 64s. These are double precision floating point numbers with a very large resolution. Strings are hold a number of characters, so a character string with up to 64 characters, and I've given you an example here of what you might have in this string. Timers, you can have a number of timers on the system, and we'll talk about those in a bit. Then you can also have the date and time stored as a type of data. So for pretty well all of these types of data, you can have data defined as inputs, outputs, or both. So inputs would be coming in from a PLC, for example, outputs going out to a PLC, as an example, or both means it can come in or go out as you want. So this data is stored in one or more, as we call, cabinets, and you define how much of each data is in each cabinet. And you can name the cabinets whatever you want, whatever's convenient for you, PLC 1, grinder PLC, and so on, as you wish. There is also an additional system cabinet for general system use. So an example of a typical installation that we have here. So on the left-hand side, we've got the cabinet. Here's the system one, and we've got 3 user cabinets. So for instance, on PLC 1, 128 digital inputs. Those would be real inputs being read from the PLC and put into the system. Digital outputs 64, these would be going out from the PLC. And digital boths, you might just use these as flags or calculations or whatever. We have 16 60-bit inputs, and these would be typically analog inputs read from the PLC, for instance, temperatures and pressures and so on. And then we have 32 timers, and this would be a typical layout that you might see on one of the installations. So for each data value, you assign it a tag, as in a name, and you call things, whatever you understand, for instance, C1 running and so on. So if a value is in cabinet PLC1, you refer to it as PLC1.C1 running, or PLC1.mixer temperature, or if it's coming in from the grinder PLC, grinder1 PLC dot grinder1 amps. And I've shown here C2 inverter, C2 inverter dot speed output, and so on. So what I'll do is show you how you define them. So here is the SuperSCADA home screen. The little green circle up here on the right hand side shows that it's connected to a system. So we click on Configure, I/O, and these are our 3 cabinets we have on this demonstration system. So if I go to Grinder PLC and just say floating point numbers. So if I want to enter something, I have to enable it first by clicking on this. That enables the system. and I want to define a new one. So just say grinder vacuum, and I can have some comment in here calculated from well, custom logic. Right, and then if I want to preset a value, I can click on this here, and I can have a value of, say, 200. And the update type means this can be set every 60 seconds or on entry, but I'm just going to leave that blank at the moment. And then once I save this, the little tick goes, and that's saved into the system. So if I go to Monitor I/O and look at our cabinet grinder PLC and the floating point numbers, here's our new value here, grinder vacuum, and here's the value that it is at the moment, 200. If I want to change that value, I can just force it by changing it to 128 or whatever, write it, and then this value gets set. Of course, it would normally be calibrated by another part of the system. So thank you for your interest in this. If you want further information, here are the contact details.